Why is an effective tunnel lighting system important? Driving in from bright sunlight into the darkness of a tunnel can be dangerous. The eyes do not get enough time to adjust to the luminescence levels inside the tunnel, because of which there is a temporary blinding effect called the black hole effect. This can cause major accidents because the drivers entering the tunnel or exiting a tunnel may not be able to react to a slowdown or stopping of the traffic. The objective of tunnel lighting is to provide adequate and comfortable visibility to enable the traffic to flow through the tunnel at adequate speeds. This is done by adjusting the lighting levels at the various lighting zones in the tunnel: the threshold zone, transition zone, interior zone, and exit zone. The initial adjustment occurs at the threshold zone to allow the driver's eyes to adapt from the daylight condition outside of the tunnel. The brightness levels are gradually reduced within the transition zone to allow the eyes to adapt to the brightness levels in the interior zone. The interior zone is the longest and the brightest levels are adjusted here based on various parameters. At the exit zone, the brightness levels are increased to the levels of the lighting condition outside the tunnel so that the eyes can easily adjust to the change in luminance levels. To ensure continuity of power, the power supply in the tunnel is backed up with DG and UPS system. Tunnel ventilation takes care of two important functions. During normal operations, tunnel ventilation helps to clear the smoke, toxic gases, dust particles, and other polluting emissions by the vehicles, thereby ensuring clear ambience and air quality. During a fire situation, ventilation systems prevent the backlayering of smoke so that commuters are safe and rescue operations are not hindered. The ventilation is done with the help of jet fans and VFD starters. The speed and direction of ventilation is controlled by the SCADA system. Using closed-loop feedback system, the fans are turned on and off as demanded by SCADA, ensuring functional efficiency while conserving energy. The system can become operational even if the control room supervisor is absent. Fire is the most feared risk that could happen in a tunnel. The prime objective of fire safety is to mitigate the fire. Rescue the victims from the site, and to stop further vehicles from entering the tunnel. The Kuthiran tunnels are twin-tube tunnels, 965 meters long, with two connecting emergency crossover passages 300 meters apart inside the tunnels. The fire safety measures adopted here are of paramount importance for the tunnel's safety operations. A fire gets detected in the early stages itself using various mechanisms. The linear heat sensing cables placed inside each tunnel in 2 rows can sense the change in temperature and alert the control room. There are temperature sensors and toxic gas sensors provided inside each tunnel that can sense the changes and alert the control room. The CCTV cameras installed in each tunnel have the incident detection system inbuilt, and the control room gets the alert visuals about the incident. Such precautionary measures provide effective fallback mechanisms, ensuring uninterrupted alerts and facilitate quick rescue operations. Control room displays always have the local hospital telephone numbers, local fire and safety office numbers, local police station numbers, and numbers of the officials concerned. The operator on duty alerts the local fire authorities and other designated officials and coordinates with the ambulance and hospital services to ensure health safety for the incident victims. The SCADA system signals the changes to the lane signage boards and the tunnel information boards. The lane signage boards will display indicators to the cross passages, and the block lane indicators are also flashed to guide and divert the vehicles that are already in the tunnel through cross passages and into the next tunnel to lead them safely out of the tunnel. The public address systems installed in each tunnel are also activated to provide verbal instructions in conjunction with the lane signage boards. The tunnel information boards located at the portals of the tunnels will help alert other vehicles from entering the tunnel. Together, these measures allow easy passage for the ambulances and fire tenders to reach the tunnel quickly. The fire is mitigated using the fire extinguishers placed every 50 meters apart and the fire hydrants placed every 50 meters apart in each tunnel. 30 HP banana jet fans have been installed at 5 locations inside each tunnel. The tunnel ventilation provided by these fans using the method of longitudinal ventilation system helps prevent the backlayering of smoke essential for unhindered rescue operations. The backlayering is prevented by the successful operation of 8 fans. 2 fans in each tunnel are considered as spare fans, as the fans in the fire-affected area may not be able to start. The SOS call stations placed 200 meters apart in each tunnel can be used to get connected to the control room operator immediately. Each tunnel has 5 SOS call station equipments installed every 200 meters apart, 9 public address systems, 3 temperature sensors and 3 toxic gas sensors, each for carbon monoxide and nitrous oxide. As part of the CCTV setup, there are 9 cameras installed in each tunnel and 1 camera each in the cross passages to effectively cover the entire tunnel. Depending on the status of the situation, the adjacent tunnel status is also changed to assist the accident victims to clear out from the location. We continue to review and update our tunnel safety measures to ensure a pleasant and safe drive for our patrons.